This is our first lesson in limits, and we just kind of dabble in limits a little bit before we move on to some bigger topics that kind of lead you into calculus. So in order to talk about a limit, we kind of want to know what they are or what the purpose of them was for. So why learn limits? Well, first off, and I kind of wrote a bunch of stuff out here for you, but usually in pre-calc we're dealing with nice continuous curves, or we have these functions that we've worked with before where they're not continuous at a few points. Or even ones where, like right here, you potentially have like an asymptote happening where you kind of climb forever. So first of all, limits give us the vocab and the math to describe and deal with discontinuities. So when functions are not connected, like what happens when this one ends, what happens when this one continues up forever. Secondly, asymptotes. So limits help us talk about what happens at the ends of asymptotes, or if we wanted to talk about what was happening at the very end of this function as it's headed up, that's where limits come in handy. And then third, using limits, it's possible to find the area for a region with a curved side. So maybe we needed to find the area under this curve, and it's not very straightforward because it's not really a semicircle. It's kind of made up of a lot of different turns. It's not just a perfect shape like you've dealt with in the past. Another place where limits are used is like to maximize or minimize something. So let's say you're trying to maximize the volume of a box but minimize the surface area. So you're trying to create a container for a product you have using the least amount of materials possible but giving you the biggest volume. So those types of problems where you're minimizing or maximizing something are also a place where limits are used. So what's a limit look like? So it has some interesting notation which is much different than we've seen before, and it starts with this LIM, kind of telling everybody you're doing the limit. And then you're identifying what your x value is going to approach. So that's kind of what that arrow stands for, is as your x approaches this number, and it will be some value like a 2 or a 5 or a 0 down here. Eventually we'll get to like doing infinity or negative infinity. So you're talking about what does, as x does this approach, as it comes towards this number, what is the function doing? So we are looking for, or the answer is, like what you're going to be telling us for an answer, is what is the y value pointing to. So as we approach this x value, what is our y value? It is really like a function that we've done in the past. If we have an x value, what will the y be that comes out? So it's still that idea. This time we're just talking with a lot with the word approach. And I'm going to show you some visuals on that. We're going to look at some graphs and tables to talk about approaching. But it's all about approaching this x value. So the first example we're just going to dive into is the limit as x approaches 5 of 2x plus 1. This is a function we have used before. It is just the equation for a line. So I'm going to go ahead and graph that. Just imagine that this is your mx plus b. So that's just your function. So my b is at 1 and my slope is up to over 1. So I'm just going to give it a sketch here. So this is the equation of this line, 2x plus 1, and I want to know what happens as x approaches 5. So right here is 5, and I have to come up to the function. There is nothing, there's no function down here, so always get up to where your function is. And then your job is to approach this 5, this dotted line, from both sides. So imagine you're using both of your fingers, and this graph goes on forever, obviously, and we're traveling on both sides towards that dotted line. And as I get to 5, we just want to know what value would my y be pointing at. And although I didn't draw it, perfectly, sorry about that. As I approach 5, as I come towards 5 for an x value, it looks like my y value is at 11. And then if you look real close, or you just ponder that for a hot second, you could probably figure out that as I approached 5, all I really had to do was plug a 5 in here. 5 times 10 plus 1 is 11. That method right there is called direct substitution. Seems kind of like a no-brainer. Plug in what you're approaching, see if you can get an answer. And you can use that as often as you possibly can. Direct substitution is a great way to go, and you always want to try it first. Lots of times, unfortunately, it is not going to work for you. Case in point, the next one. Here we're approaching the limit as we're doing the limit as x approaches 2. But if I plug a 2 in down here, I'm going to get 0. I can't divide by 0. And if I plug a 2 in up here, 2 squared is 4, 4 minus 4 is 0. We actually have 0 over 0, which is called the indeterminate. can't figure anything out from that. The answer is not 0. The answer is not undefined. It just means that direct substitution didn't work. So we're going to try graphing it. We're going to take a look at the table that it creates. So go to your y equals. We're going to type in this equation. I'm just going to make sure I have parentheses around my numerator and around my denominator. So I've got an x squared minus 4 and then divided by x minus 2. Remember, we always want to hit zoom 6. Go back to that standard looking window. There's my graph, kind of interesting, just looks like a line again, which is a little not intuitive because that's a squared, which we know are parabolas. So that's kind of an interesting graph result of that function. And our job is to approach 2. So then I like to tell students kind of lay your pencil on 2. So we're going to attempt to draw an imaginary dotted line, kind of like we did here. A little tougher on your calculator screen. So put your pencil at 2, and then your job is to try and figure out what that y value is. Now, I don't know about you, but that is super pixelated. Like, I'm not entirely sure where this meets, where it goes over. So sometimes I use the graph as just a visual. Like, I can tell that the answer is going to be about maybe 3, 4. Like, I just have a good idea of where it is, not quite exactly what it is. So I'm going to teach you a new feature today, and it is our table. We can actually look at a table of values like a giant XY chart that your calculator makes anytime it graphs. So if you go to second table, you can actually see a whole bunch of values. So your calculator plugged in a 0, it got 2, and it plotted that point. It plugged in 0.03, it got 2.03, and it plotted that point. This is just a giant XY chart of a whole infinite amount of values that your calculator plugged in order to produce that graph. But we only really care about one place on this graph. We only care about when x approaches 2. So I'm hitting second table again. So I don't really care about negative 0.36. I don't care about negative 0.3. I really only care about approaching 2. So I want to control my table. I also do not want to sit here with my finger on this up-down arrow and hope that I eventually get to 2. This will take all day. And depending on how your table is set, yours might look completely different than mine. So we kind of want to all be speaking the same language when we're doing a table. So to do that, I'm going to do second table set, which is actually your window button. And here's where you get to control your table. So that first part, table start, you're saying where do you want your table to start? You can pick any number you want. I would actually like it to start at 2. It's the only number I really care about, so let's just get focused in on that. The next part, the triangle from science class, that means delta, that means change. So it's saying how much do you want your table to change by? So when you go to make your XY chart, typically you make your XY chart going by ones. -2, -1, 0, 1, 2. That's usually what we do. We don't usually dabble in decimals because it just takes a lot more space to fill out your XY chart. What's lovely about your calculator is you can ask it to do decimals because it can do them in a second, and then they're all computed for you. So I like to start with a 0.1 table, and then I'm going to show you how your answers change the more specific your table gets. So once you decide that you want to start at 2, because that's what you're approaching, I started my table at 0.1 just to give us something to begin with. I hit second table again, and now it starts at 2. And there's an error there, which we already knew because we plugged in a 2 and we got 0 over 0, and that was no bueno. So what I like to do is put the 2 in the middle of my table, in the middle of my screen essentially. So I'm just going to arrow up a little bit. I'm going to bring that 2 kind of in the middle so I can look at it. Remember, your job is to approach 2. I don't really care what happens at 2 because that's a big problem for us. So as we approach 2, we want to know what our y value is doing. So on this side, it looks like I went 4.3, 4.2, 4.1. I can make a pretty good guess about where that's going to land right there. This side went 3.7, 3.8, 3.9. I have a pretty good feeling that on both sides, as I climb towards 2, my y values are climbing towards 4. But just to give you a better appreciation for that actually being a 4, maybe these numbers are too far apart and you can't quite tell in the next problem. So I'm going to go back to table set. I'm going to ask it to start at 2 again, and I'm just going to make this go smaller. So I'm asking my table to get more specific, go to a smaller decimal, a smaller increment of change. So when I hit table this time and put my 2 in the middle, now I'm getting an extra decimal place. So now I'm doing 4.03 and then 4.02 and then 4.01. And this side's going 3.97, 3.98, 3.99. It's like even more convincing that you're headed right towards 4. And I don't want you to see these two numbers and think I'm going to average those two. That's not it. I don't want you to get in that habit. I just want you to think about what would the number be in the middle if it could get there. What do these numbers look like they are approaching? We don't know exactly what happens at 2, but we're making a good guess off of the pattern that we're seeing from both sides of that data. So this limit as x approaches 2 of that function is a 4. We're going to try the next one and do the exact same thing. I'm going to type this one in and make sure that you put parentheses around your entire denominator, otherwise that's where things are going to get messed up. So you got an x divided by parenthesis, and then I've got the square root of x plus 1 with a minus 1 and your parenthesis. I'm going to again hit zoom 6. I just want to take a peek at it. Okay, that's an interesting graph. Remember that you are finding the limit as x approaches 0. So here's 0 for x's right there. Looks like it's about 2-ish. So now I know when I go to find my actual answer in my table, I kind of know around what my answer is going to be. Somewhere between 2 and 3, I can kind of tell it's in there. So table set. This time I want to start at 0. That's what I'm approaching, so it's really the only number I care about. I'll start with 0.01. For my table, we'll see if we need to get any more specific than that. And I'm going to hit second table. Put my 0 right in the middle of my screen so I can approach it from both sides. Looks like I'm going 2.01, 2.01, 2.005. So that got smaller and smaller, headed towards 2. This one's 1.984, 1.989, 1.995. So that's climbing just tiny, tiny bits. Looks like we're headed right to 2. Oh boy, on the next page. This time we're going to try tackling a piecewise function, a little different concept in terms of approach. So the very first one we did, we graphed it, no big deal. The next two we did, we used our calculator to graph. This time we're going to graph it by hand, doing just all of our work with piecewise that we've done earlier this year. So two piecewise functions, and I'm going to make two xy charts. So this one's going to be right here, and this one's going to be right here. Remember, when we did piecewise, you always want to start with the number that your x is centered on, and you want to go in its direction. So this says x has to be greater than 2, so we want to start at 2 and then go greater. This one says x should be less than or equal to 2, so we want to start at 2 and go smaller. So plugging a 2 in up here, 2 plus 3 is 5, 3 plus 3 is 6, 4 plus 3 is 7. And then down here, plugging in a 2 would give me -2, a -1, and a 0. So I'm going to plot these just in that order. So 2, 5, open circle, 3, 6, 4, 7, and I'm connecting in that order. So the way that I put them in my chart tells me how I connect. Next I've got a 2, -2, filled in circle, 1, -1, and 0, 0, and I'm connecting in that order. So there's my piecewise function. And my job is to find the limit as x approaches 2. So right here is 2. I'm just going to make a light dotted line. And remember, as you're approaching from both sides, requires both fingers on the picture, you're trying to figure out what your y value is doing. So as I am on this side of the dotted line and I'm approaching the dotted line, this is the line I'm following in. It's kind of like driving on a road. This is the only road on this side of the highway. Coming this way. This side only gives me this road. So I'm driving this road in. I end up way down here. I drive this road in. I end up way up here. If your fingers are not coming together at a single value, this limit does not exist. I can't come to one value. I'm not approaching the same thing on both sides, like this one. We were approaching 11 on both sides. Both the ones we did in the calculator, my fingers were coming to the exact same y value. We were climbing towards 4, or we were climbing towards, what was the other one, 2. This one, both sides of my function were coming towards different values entirely. I had one y value down here, I had one y value way up there. So it does not exist. Next, we're going to try the limit as x approaches 0. So here's 0. Imagine another dotted line there. Or you could lay your pencil there and kind of point at it, except that rolled. And then we are going to approach from both sides. So this road is coming towards a 0. I don't use this one because this doesn't reach 0 yet. This one's even closer, so I want to get as close to 0 as humanly possible. Don't let your eye be fooled by arrows. You're not following it that way. You're coming towards 0. And both of my fingers, as I come towards 0, point to the exact same thing, and that is a y value of 0. Remember, this is your x, this is your y. This is your x, this is your y. We're going to approach 8, and we're going to find our y value. 8's off the chart, right about there. So I know my answer is going to be up here somewhere. That function is just going to continue until that value. So all I really need to do is focus on this part of the equation, which was the stuff greater than 2. And I can do my direct substitution by just plugging an 8 in there. Sorry, my lights just went off. There we go. So if I plug an 8 in there, 8 plus 3 would be 11. So if we continued this graph until we made it to 8, both of those sides would approach positive 11. Oops, sorry, my fingers were off the graph, or off the picture. So you would approach 8 and find out that both sides were coming towards 11. Now a couple limits that fail to exist, much like this one did not exist. We're going to graph these again so we can get a good picture of them. So I'm going to graph absolute value of x. If you don't remember where that is, under the math menu, and if you go over to number, your first option should be absolute value. Yours may or may not do the vertical bars. You might just have parentheses, so make sure you close that off before you hit divide by. Zoom 6 graph should look like this. That's an interesting graph. And we are approaching 0. So imagine my dotted line is right here. Fingers on both sides of the function, kind of driving on those roads coming towards 0. And as I do that, my left finger is headed towards -1. My right finger is headed towards +1. So that limit does not exist. My fingers are going into different places. I'm not coming together in one value, to one value. Next up, I've got the limit as you approach 0 of 1 over x squared. So if we tried direct substitution and plug a 0 in there, 0 squared is 0. We can't divide by 0, so we're kind of in a pickle. So we got to come graph it and see what it will show us, x squared. Zoom 6ing again. That's an interesting graph. Okay, so I am still approaching 0, which is right here in the middle. Put both fingers on one side, one on each side. And as you start to approach 0, as you attempt to move your fingers closer to 0, and you have to follow your roads just lead you straight up forever. So we call that limit does not exist since we can't ever get up there. That limit would be d and e. So that is your very first day of limits. We're going to do a lot of approaching things, approaching your x value. Today you're either going to be doing some direct substitution, a couple of piecewise, or using your calculator to graph them.